Hello, dear students. Today we are going to learn curve tracing in parametric form. Curve tracing in parametric form. In previous lectures, we learned how to trace the curve in Cartesian equation form, and today we are going to learn parametric equations. So, what is meant by parametric equations? Nothing but x is a functions of one parameter, say it is t, and y is also functions of another parameter, another function g of t. Here t is a parameter. T is the parameter for both the functions. Now, such cases, such equations, how to construct the curves. In case of theta t, they may ask here theta or any other values are like that. These are the parameters. These are the parameters. Or a, sometimes a they ask you a parameter. So depending on the given parameter, we have to construct the curve for the given equations. Now, mainly we are going to learn these are the concepts for tracing the curve. First is symmetry. Symmetry of the curve you have to find out from the equation. Now, check whether the curve is passing through origin or not. You have to check. And third point, whether the curve have a tangent or no. And where the curve is absent, you have to find out. And construct a table which containing a parameter t, x and y values, x and y values. These are the main factors to construct a parametric equations of a curve. Now we'll learn one by one concepts. Now first we'll go for symmetry. Now how to find out whether the curve is symmetric about which axis is. Okay. Now this is the first point we can learn. Now we have two functions here, f of t and g of t, or f of theta or g of theta. Now out of these two, find out which is even or odd function. Even or odd function. If f of t is even function and g of t is odd function, then you say that curve is symmetric about x-axis. Curve is symmetric about x-axis. Now, how to find out odd or even function? Replace ty minus t. Function does not changes its value. Then you say that it is even function. And you replace t by minus t. The function changes its sign. And it is same. Then you say it is odd function. Okay, this is first condition. If replace t by minus t, the function becomes odd or even. Then check it. If ft is even function, then it is symmetry about x-axis, and gt is odd function. This is the first condition. Now, second condition. Check in the reverse order. If f of t is odd and g of t is even function, then curve is symmetric about y-axis. About y-axis. Now, next, if curve is, if both f of t both f of t and g of t are even function, both are even function, then curve is symmetric about x equal to y line. And if both are odd function, the curve is symmetric about opposite quadrant. Symmetry about opposite quadrant. Opposite quadrant. Symmetry about opposite quadrant for odd functions. Now, next point D is that the value of t and replaced by t by minus t, then x remains unchanged. X function remains unchanged. X remains unchanged, and y you get equal and opposite value. Opposite value means sign change in the magnitude. Then curve is symmetric about x-axis. Symmetric about x-axis. Be careful of once. I'll repeat once again. If you replace the function t by minus t, the x is unchanged. Y got equal and opposite value. Then the curve is symmetric about x-axis. Curve is symmetric about x-axis. Now, second question: if replace t by pi minus t, and y remains unchanged, y remains unchanged, y remains unchanged, then you say that curve is symmetric about y-axis. Symmetric about y-axis. T by minus t, t by pi minus t. Then if you replace t by minus t, the curve is symmetric about, if x is unchanged, then symmetry about x-axis. Replace t by pi minus t and y remains unchanged, then curve is symmetric about y-axis. Curve symmetric about y-axis. These are points about the symmetry. Now, next point is check whether the curve is passing through origin or not. Check whether the curve is passing through origin or not. Put x equal to 0 and get value of parameter, set t, and use that t, find value of y, If y also gets 0, x is 0, then y also got 0, means given curve is passing through origin. Given curve is passing through origin. Okay, vice versa. Report, or you can write into another form also, vice versa form. Let's replace y equal to 0, find a t value, and use that t value, get value of x. That is the one method to calculate whether the curve is passing through origin or not. Also, you can find out the equation of asymptotes or tangents. tangents to the curve. Similarly, again calculate dy by dx is equal to dy by dt parametric equation form and dx upon dt is parametric equations. And for value of t, calculate dy by dx at a some value of at some point t, whether this is 0 or plus or minus infinity. If it is 0 or plus or minus infinity, if it is 0, then you say that curve is symmetric about the tangent is parallel to x-axis or axis itself. And if you get it's infinity plus or minus infinity, then tangent is parallel to y-axis. Tangent is parallel to axis or itself, and here x-axis or 0. Now, next point is how to find out region of abstention. Region of abstention. Region of abstention. For this, we will use a table containing a t parameter t, x variable and y variable. These are functions. X is functions of t, y is functions of t. Then you get here you can construct a table which containing this t and x, y. T, x and y. Now this is a very important concept here, constructing table of t, x and y. Now mostly select parameter, selection of parameter. Here you can take 0, some depending on your values of parameter, pi by 2, then 5, then take 3 pi by 2, then take 2 pi, take or a, it may be select as a, b also. If parameter is theta, you can take angle form. If parameter is t form, you can take numerical values. You can say numerical values, you can say a, b, c is depending on the your things. Now this you can assume that, and by using this values, find out value of x, value of y. Again here x2, x2 value, then you get y2 value, x3, then y3, and so on. You find out point. Now while finding such points, if you got any values infinity, then you say that the curve is absent for that point or that parameter. Curve is absent for that parameter. Okay. Now this you have to construct the testing of the curve. Now we will go for next one hour examples how to trace the curve. Assume that I'll take one example. Here asteroid, I'll take asteroid. Asteroid curve. Asteroid curve equations are x raised to 2 by 3, y raised to 2 by 3 is equal to a raised to 2 by 3. This is standard equation of curve in Cartesian form. And this curve can be also solved with parametric form also. That is, parametric form is x equal to a into cos cube theta or cos cube t, and y equal to a sin cube t or sin cube theta. Now here we have t as a parameter. We have t as a parameter, or t is a parameter. T is parameter. Now, how to construct such curves? First point, check symmetry. In symmetry, we have rules. If you replace t by minus t, that is odd or even type. Odd functions or even functions. Now here f of t is equal to x. You can say this is nothing but a cos cube t. And I write here g of t. G of t is nothing but here your y is equal to a sine cube t. A sine cube t. If you replace t by minus t, this becomes x equal to a into cos cube t itself only. Why? Cos of minus t equal to cos plus t. Cos of minus t equal to cos plus t. Here is unchanging. Okay. Here unchanging. Similarly, we replace g of t by minus t. Okay. G of t equal to minus t, then equal to y a into, then we get here minus sine t, nothing but minus sine cube t. Therefore, we get minus a sine cube t. Here y you got odd function. Y you got odd function. Now here f of t, that is x, f of t is even function. Y, that is g of t, y is here g of t. Then g here odd function. Therefore, curve is symmetric about x-axis. Symmetric about x-axis. Now, second point, replace t by pi minus t. Replace t by pi minus t. Then y has same value. Y same value. Sine of pi minus t is same as sine t. Therefore, g of pi minus t is equal to g of t. G of t. And x will get opposite value. X will get opposite value. Therefore, even though symmetric about y-axis also. Symmetric about y-axis. Now, and once you highlight it, if f of x is even function and g of t, nothing but y, is odd function, then symmetry about x-axis. So similarly, you change t by pi minus t. By changing t by pi minus t, then you get x, you got opposite and equal values. Now check it. F of t is equal to x, and you replace t by pi minus t is equal to x equal to a into cos pi minus t raised to 3, or bracket cube. Cos pi minus t is which quadrant? Pi minus t is second quadrant. Sine is positive, cos is negative. Therefore, x equal to a into minus cos t bracket raised to 3 becomes minus a cos cube t. This is opposite value. Opposite value. So it is x is opposite values of the function. And y, we get no change in y. Therefore, symmetry about y-axis. This is a second test for the y testing. Replace t by pi minus t. T by pi minus t means once you put t equal to minus t and second times put t equal to pi minus t. This is the two test for the symmetry about the axes. Now we got this curve is symmetry about both the axes. Symmetry about both the axes. Now our next point is check whether the curve is passing through origin or not. Curve is passing through origin or not. Just I told you this, how to find out originality. Put x equal to 0, that is f of t equal to x equal to a cos cube t. A cos cube t. Yes, 0 x is 0. A cos cube t equal to 0. Therefore cos cube t equal to 0. Then t, which value of t we get 0. Then cos is 0 only for pi by 2 or 3 pi by 2. Pi by 2 or 3 pi by 2. Now if t is pi by 2, then find out value of y. This value of pi by 2 put into the second value of function, that is g of t. The g of t, that is g of t. G of t is nothing but a sine cube t, and put value of sine is pi by 2. Pi by 2 is 1. 1 cube is 1. Therefore y you get equal to f. Y you get equal to f. Then here we got, by putting x equal to 0, we get value of y equal to also the values x equal to y equal to f. By putting x equal to 0, this finite value we get. Finite value you got. Therefore curve is passing through the origins. Curve is passing through origin. As well as now here you got x y equal to f. Y equal to, but here y is not got 0. Therefore curve is not passing through origin. Not passing through origin. Why? We got here value of y equal to a. Value of y equal to a, that is not equal to 0. Therefore we got, which means as x equal to 0, we got y got a. X equal to 0, y got a, means our curve is intersecting y axis at 0, a point. 0 at a point, plus or minus. Okay. Now similarly we put y equal to 0. Y equal to 0. Similarly check find out value of t. Find out value of t. Then you get x equal to f. Therefore you got one more point a0. Here also you get the curve is not passing through origin, but it intersecting the coordinate axes. The symmetric about both the axes, not passing through origin. Then go for next point for next we'll check for tangency. Third point, tangency. Third point is tangency. Calculate dy by dx. Dy by dx is equal to dy by dt upon dx upon dt, and this you get minus tan t. Minus tan t. Now dy by dx at 90 degree, t equal to pi by 2 or t equal to 0, both the equations. If t equal to pi by 2, you get plus infinity, and t equal to 0, you get 0. Okay. This means y axis is also tangent x-axis also a tangent to the curve. X-axis also tangent to the curve. Now, after the tangent, we will go for the eccentric curves. Curve eccentric. How to find out whether the curve is present or eccentric? Now, prepare a table. Now, this is a table which helps to us to get. Take t, x and y, 0, pi by 2, 5, 3 pi by 2, 2 pi, 2, 5, we get value of x here 8, then 0, minus 8, 0, 8, 0, we get value of y 8, 0, a and 0. Okay, now you get like this values of x and y, they will come. And from that you can construct the curves. Now I'll construct here like this curve. Curve symmetric about both axes means equally you have to write out. This is x-axis, y-axis, x dash and y dash. Axes you can make it arrows. And we got some points on the axes, and that is a0, 0 a, 0 a, same as minus a, 0 and 0 minus a, and you get the loop is like this, passing through sphere, passing through this curves. Asteroid, we get this curve, loop curve. This is asteroid curve. Exactly not getting here. We do this is whiteboard. Okay, this is a asteroid curve. Okay, like that you can construct any curves. Let's learn you one more example. Example number 2. X equal to a into t sine t, y equal to a into 1 minus cos t. Such cases here x is equal to f of t, y equal to again g of t, f of t and g of t are two functions. Now you replace t by minus t, check symmetry conditions, symmetric condition. Here replace t by minus t, and f of t becomes odd, and g of t is even function. Indicate that symmetry about y-axis, symmetry about y-axis, symmetry about y-axis. Even function, which is even function here? G of t is even function. G of t even function is symmetry about y-axis. Now check originality. Check whether the curve is passing through origin or not. Then put y equal to 0 or x equal to 0. Y equal to 0. Therefore 1 minus cos t equal to 0. Cos t equal to 0. Therefore t equal to, again you get 0. That is cos t equal to 1. Therefore t equal to 0. Then t equal to 0, from t equal to 0 get value of x, to get x equal to 0, therefore 0 0 is the point where the curve is passing through origin. Now here the curve is passing through origin. Third point, talk about tangent divided by dx at the each point divided by dx. Divided by dx will get here tan t by 2, tan t by 2 at t equal to 0. For t equal to pi by 2, we get plus or minus infinity, tangent to curve at infinity means y-axis. X is also tangent, y-axis also tangent to the curve. Then how to construct the table? Guys, important is table t, x and y. 0, pi by 2, 5, 3 pi by 2 and 2 pi. 0, a into pi by 2 minus 1 and 8 pi, then a into 3 pi of 1 minus 1, 2a pi, then you have y0, then a, 2a, a and 0. These are the value of x. Then you get curve like this. You get axis, symmetry about y-axis means you can take it y. This is a and 2a and a, the limits of y's. This you get here, a and 2a are the upper limits. Now we take here a pi, then here a into 3 pi by 2 minus 1, 2a pi, and here a into pi by 2 minus 1 and 0. One side curves. Then t is pi by 2. When t equal to pi by 2, t equal to 0, curve is passing through origin. And here. Then here curve passing through origin, symmetry about y-axis. And here also same symmetry about axis. But if curve is the side, this side. Again curve is taking loop. Curve is taking 2 plus. And here same curve is going this side. Taking loop. This is a cycloid curve. Okay, we stop here only.